Good day. In this dataset, we are analyzing the iris dataset to classify the three different species of iris. So we first of all load the libraries. So use TensorFlow, Pandas, Seaborn, Matplotlib, and sklearn. Then we load the data using from the iris CSV file, and then display it in a data frame. And from there we drop the ID column because we will not be using it, and then we display the output. From there we rename the columns so that they're easier to read and also easier to manage. So for example, for sepal length, we rename it to sepal space length, and sepal width, we rename it to sepal space width. Then we display the output to verify that the renaming process has completed successfully. And from there, we remove the missing and duplicate values using isNA and also duplicated methods respectively. In this case, there are three duplicates, so we use the drop underscore duplicates method to drop the duplicates, and then sort the index on the column on a column basis, and then display the output. Then we manually encode the classes by using these labels: iris-setosa, iris-versicolor, iris-virginica, and then count the different classes. So in this case, you can see that iris-versicolor is 50, iris-virginica is 49, iris-setosa is 48. Then we visualize the results on a graph, and then we do manual encoding for each individual value. So this is the manual encoding process. We look through the 150, the total number of values, like this is 99 plus that, it comes to 157. So we look through, sorry, 147. So we look through the 147 values to manually encode them to the different values. So iris setosa is 0, iris versicolor is 1, iris virginica is 2. So then we display the output. This is the output, and then we also plot it on a graph. Then we visualize the different columns against each other using a pair plot. It used to compare more than two variables. So this is the output. So there is sepal length, sepal width, petal width against sepal length, sepal width, petal length, and petal width. In this graph, the first one is the iris setosa. Then the second one is iris versicolor. The third one is iris virginica. As the graph descends towards the bottom right, the iris setosa is slowly separated from the other two classes. So in this case, you can see that iris setosa, for example, to this section, the iris setosa is to the left, and the iris virginica and iris versicolor are to the right. So it's very hard to separate the two. So in the last bottom right, you can see that iris setosa is to the left, it's completely separated from the others, while iris versicolor and iris virginica still tied at the bottom. Then we prepare the data by dropping the species column so that you can get the features for that will be the X section, and then we take the species as the Y section because it's the dependent variable. Then we use k-means clustering to create a model that fit on the X values so that you can predict the Y values. We verify the centroids created by the model using cluster underscore centers underscore attribute. This displays these values to display how far from the center the values are moved. And then we plot the original cluster versus the k-means cluster on a graph. And then we set the hue for the original cluster as Y, and then hue for the k-means cluster as Y pred, which is the predicted value values using the k-means algorithm. This is the output on the graph, in the original cluster to the bottom left. This is the first species, which is iris setosa. Then the second one, which is iris versicolor. Then the third one, which is iris virginica. But for k-means clustering, it has somehow misclassified the values that it has found 5 classes instead of 3 classes. So the k-means algorithm needs to be optimized. To optimize the k-means algorithm, we use an elbow curve. So to plot the elbow curve, we look through 10 values in this case, and then we fit those 10 individual models on the data, and then from there we append any errors that occur in the for the model to this list, and then we use that to plot an elbow curve. So this is the elbow curve. The elbow curve, to determine an optimum point from the elbow curve, you select the point whereby the elbow curve starts to stabilize and be plateau. So in this case, the point whereby that starts to happen is when the error is 3. So that will be the optimal that will be the optimal cluster size for the k-means algorithm, and we use it to create the k-means model. So we recreate the model, but now the cluster size has been set to 3. Previously it was set to 5. This section it was set to 5, so we need to set it to 3. Then we recreate the model and replot the graphs. So in this case, the k-means algorithm correctly identifies the different classes as 0, 1, and 2. And then we can check the differences between the k-means algorithm and the original cluster. So the original cluster had 48 values for iris setosa, 50 for iris versicolor, and 49 for iris virginica. The k-means cluster, on the other hand, has 60 values for the iris setosa, 39 for iris versicolor, and 48 for iris virginica. Thank you.